Hi, my name is Tom Hartka. I'm a faculty member here at the University of Virginia, and this is part of the asynchronous learning series for the resident education in emergency medicine. What I want to do today is cover some of the basics of R, which is a statistical programming language. This is part of the lecture series I'm developing on research methods and statistics. I think one of the best ways to understand statistics is to really be able to delve in, look at the data, try the tests with multiple types of data, change your sample size and see how that affects your results. And the basis of this, I want to do this in R. There are multiple um, statistical programming languages out there, but R is free and it's easily accessible. So that's why I'm using R. And today I'm just going to cover some of the fundamentals of doing that. First, I want to show you a little bit about how to use R and the different methods. One way to do it is to download and install RStudio. This sits on top of the R programming language and it just makes it easy to use. You have code up here in one block, you have your output here, variables here, and you can view plots and files down there. And this is great. Unfortunately, it requires that you install R on your computer. That can take up a lot of resources and be a little time intensive. Another way to run R is through a Jupyter notebook. And these are notebooks that contain blocks that are either text or code. And on the back end, R could be running on your computer or it could be running on someone else's computer, which is pretty cool. It turns out Google actually has a they've developed this thing called Colab, which lets you run Jupyter notebooks actually on their server. So you're not even using it. You don't have to install anything. You're not using any of your resources. And that's what I want to show you today. So Colab is actually made to run Python notebooks, and we want to use R, which is a different programming language, but there's actually a way to do that. If you enter this address, https://colab.to/R, if you enter that, it will take you to a notebook that is running R. If we go into runtime, we can see it's running R instead of Python. So again, this is a Python notebook. It's these blocks are either text or code. The text is in what's called Markdown language, which you can look into, but it basically it's a way to format text. If you put a hash sign, then a space, and then let's say we'll call this introduction to R, and then we could say created by Thomas Hartka. And then if you push shift and then enter, it executes the block. And if it's text, it just means it makes it into text. Again, I'm going to add another code block here and says notebook running R, go to um, all right, let's get started. So I want to cover the basics of using R, and I think there are four important things. One is to be able to assign values to variables. The next is an if statement. After that's a for loop, and then finally we're going to cover functions. And these are really the basics of any programming language, and I think they're all pretty easy in R. Um, So now I'm going to put actually 2 hash signs, so it just makes it a slightly smaller heading. And we're going to say variable assignment. So if you've taken algebra, you know what variables are. We'll start with x. We'll say assign 8 to x. So x is 8. So in R, we use this arrow, which is just a less than sign followed by a dash. And we're going to assign 8 to x. And again, I do that, and then I push shift and enter, and that executes that block of code. I'm just going to say x here, and we see x now contains 8. And we can change that to something else if we want. Make it 6, and now that equals 6, and it's pretty straightforward. R uses this arrow operator. If you actually use an equal sign, it works, but by convention, the arrow is preferred. And now that we have this, we can square it. So this caret sign means exponential, so that's x to the second power. And we see that we now have 8 squared if we run this. Again, we see our latest assignment was 8. If we switch it back to 6, we'll get 36. You can actually assign a list to a variable. So if you do C parentheses inside this is the list you want to do. And now we look at X, and it now contains a list. So you can put just about anything you want into a variable. You can put an entire data set into one variable, and we'll cover that in other lectures. It's pretty cool too if you have a list like this. You can square it, and it actually goes and squares each number inside that list. You can add values to this list. So you call this function called append. And I'm going to talk about what functions are a little bit later, but we say append, we send it the variable that contains the list, and now let's add another value. And we see it added 5 there. One thing is, though, that I call it append, and it added a value, but we didn't store that new value. So let's actually append it and store it back to X. And now if we look at X, it contains 5. One thing you can also do is an empty list. So if we look at Y now, there's no values in Y, so it says it's null. And then we could append to Y, and we could actually, instead of a value, do a list. And now we see that Y now contains some values. All right, the next thing I want to cover is an if statement. So this is basic what they call flow control for programming. Sometimes you want to run some code if you have a certain condition, and other code if you have a different condition. So let's say if x equals x, we're going to print a message. Oh, and if you're in a code block and you put a hash sign, that means it's a comment. So that is a line that's not executed. And it just helps people be able to read your code, or yourself to read your code and know what you were thinking. So this is an if statement. So I'm going to say if, and then in parentheses, I'm going to put a test condition. I'm going to say if x equals 8. So if you're checking for equality, you use 2 equal signs. So if I want to check if x equals 8, I use 2 equal signs. If I want to assign 8 to x, I can do that with a single equal sign. And that's pretty common in programming languages to use this double equal sign. So if this condition is true, then it's going to execute this code. And this command just says print whatever in this quote to the screen. Else, I'm going to say print x does not equal 8. So the way this works is the kernel is going to come down here. It's going to look at this statement. If it's true, it's going to run this line. If it's false, it's going to run this line. Oh, and I forgot. X is a list. So let's say y equals 8. And now we're going to check for y equals 8. So y does equal 8. Now let's change y to 7. If we run it again, y does not equal 8. It's pretty straightforward. And actually, the way it's working is it's evaluating this, and it's just determining if it's true or false. I could actually write true here. So basically, if that statement is true, it runs this code. If it's false, it runs that code. So it gets here, true means true. So it does that. If I were to change this to false, it would run this other block of code. All right, next is the for loop. So let's loop through numbers 1 to 5. So a lot of times you just want to iterate through numbers in a list or a sequence of numbers. So to do that, you say for, and then you make up a variable. We'll call it index in, and then let's give it a list of odd numbers. So it's going to loop through each of these numbers and assign them to index in turn. So we'll print index equals, and in addition to printing text strings, you can print out variables too. So we're going to print this line, this string, which is in quotes, which just means it's text, and then we're going to print out the variable value. And we see it runs this 4 times because we have 4 values. The first time index equals 1, second time index equals 3, and so on. We can do this instead for a list. Remember, x contains a list, so we can iterate through each of those values that are in x, because we remember x has 1, 2, 3, 4, 5. So it just runs this 5 times, and each time index has a different value. And lastly, let's talk about functions. So a lot of times we have code that we would just run over and over, and you could just kind of copy and paste it down the page. But then anytime you want to make any adjustment to that code, you would have to change each one. What you can do instead is to take that code and put it in a function. And the function just accepts some input and then returns an output. So let's make a function to square a number. the way we do this is we create the name of the function. So we say square, we're going to call it square. And then we assign it a function. And then inside these parentheses is the input variable. And this is kind of just a placeholder name because we can pass it whatever we want. And now let's create an output variable that is the input variable, and we're going to use that caret sign again. And then we say return the output variable. And then we run that. Nothing actually happens because we're just assigning this function a name. But now we can call this function called square. We pass it 6, we get 36. So what's happening is it's taking this number, assigning it to input variable, running this code, which squares 6 and assigns it to output variable, and then it returns output variable. And we can take that output and assign it to a variable if we want to store it. Now we see y has 36 in it. And you can have multiple, you can pass multiple parameters to a function. So let's do divide. And the order of the parameters matters. So we're going to put input variable 1, input variable 2, our output variable. We're going to assign input. And you can see where this pops up. If you have the, it kind of auto fills for you. So you can find what you want, just hit tab and it will complete it for you. All right, so now we have a function called divide. So we divide 12 by 4. We should get 3. But again, the order matters because the first thing we send is variable 1. The second thing we send is variable 2. If we switch this order, we get a 3rd, which is what we expect. And now I just want to mention libraries real quick. So libraries, you can imagine lots of people wind up writing the same functions over and over because there are common things people want to do. So people actually write these functions, store them in libraries, and then you can load libraries. So there are a lot of built-in functions in R because it's made to do statistics. Like rnorm is a function, and you pass it the number of random numbers you want from a normal distribution, and you see we get 5 numbers here. But there are other things like a common plotting visualization tool is called ggplot. If I try to call ggplot, I get this error because it can't find that function anywhere. So if I load the library that contains that function and a lot of other functions, it's called ggplot2, by using this library command. Now if I call ggplot, it works. And it's just giving me an empty plot here because I haven't given it any data, but we can see it works now. And that's it. There'll be a link to this notebook, and I'm going to add a few other comments, and you can go through this. My intention is that this is a short video that you can just review each time we're working in R, just to make sure you have the basics down. And then we're going to discuss this in lecture, and you can ask me any questions at that time. Thanks for watching.